Hello students, this is going to be a quick video explaining how to use your calculator to find exponential regression. So we're doing the worksheet where we're asked to find the population of a city. So it looks something like this. We've got writing exponential power functions, etc. What city do you live? Well, put down the city in which you live. I went with St. Paul, Minnesota, which is where I grew up, just to be different from the cities that you are from. Looked up the population using Google and found the population in each of these years is as follows. Now, what I want you to do is use your graphing calculator to find an exponential model for the population growth or decline of your city. The way you do that is you're going to use x or the x values of 0 for 1950, 10 for 1960, 20 for 1970, etc. So we're describing it in terms of years since 1950. Now, to show you how I do that on my calculator, if I go back to the main screen, I would go to the Stat menu and then Edit. So Stat Edit allows me to enter data into lists of my calculator. I've already done that for my data. I've entered in list 1 the years 0 through 60, representing 1950, 1960, 1970, etc. In list 2, I've put the corresponding population for that particular year. If you need to pause and do that for your data right now, go ahead and do so. Hopefully that was enough time. And now we're going to continue on with the next step. So I'm asked to find an exponential model. So one thing I want you to do is I want to make a scatter plot of this data first. To do that on my calculator, it says stat plot right here above y equals. So I'll hit second and then the y equals button to access the stat plot menu. Scatter plot 1 is off. I'll hit enter to turn it on. And it takes me to the menu. Hit enter to turn it on again. As for type, the scatter plot is the first one. That's the one that we want. X list of L1, that's where we put the X values, the years in this case, and the Y's, the corresponding populations, are in L2, so that's good to go. For marking a color, you can do whatever you like. I don't care. When I'm ready, I hit graph, and I'm going to be disappointed because probably don't see anything. In this case, I have a logarithm graph or 2 that we did in class today. I'm going to go to my Y equals menu and get rid of those. Notice because I have the scatter plot turned on, that plot 1 is highlighted. If something happens later where your calculator is an error message, it may be because that scatter plot remained turned on and it doesn't want to be. So for future reference, to turn that off, you hit the up arrow, maybe hit over, depending on your style of calculator. If you hit enter, it'll just turn it off. Okay, I'm gonna leave it on because I'm graphing right now. Going back to the graph, disappointed to not see anything. So with statistics, I need to set my window so I can see the data points. While hitting the zoom button is very easy because in the zoom menu, the 9th option is to zoom to the statistics, zoom stat. So zoom 9 fits a nice, wonderful window. I got some goofy looking data because the population of St. Paul was pretty high and then all of a sudden a drastic drop and is now slowly climbing back up. So this isn't going to be a great exponential model, but what the heck, we'll see what happens anyway, just to show you the steps, and maybe your city will follow more of an exponential growth pattern. Now, to find the equation, the exponential model, we're going to hit the stat button once again. This time we're going to calculate something, which means hit the right arrow to go to the calc menu. In the calc menu, we want exponential regression. Well, that can be found by scrolling way down, or if you need to go to the bottom, you hit the up arrow a couple times instead. Expreg is exponential regression. It's going to find the best fitting exponential model for our data, and that's what our goal is at the moment. Choose that option, hit enter. Our X list is L1, our Y list is L2. That's great, all good things. Frequency list, leave that blank. Now, older calculators will look a little bit different in that all you'll see is this Expreg thing at the top, and that's it. Newer calculators look like this. Old calculators we'll talk to you in just a second, so hold on. To store the regression equation is something I actually want you to do because I want you to be able to graph this quickly and easily. Newer calculators, if you have store reg EQ, I'm going to store this regression equation as function y1. To access that, I hit the alpha key, and then F4 is what I'm working for here. F4 is the y variables menu. I choose function y1, hit enter. So this means it's going to store my regression equation, whatever it happens to be, as function y1 and then graph it for me, which is going to be pretty cool. When I'm ready, I hit enter on calculate, and it spits out my equation. Might take a little bit here. Okay, a times b to the x, that's what an exponential equation is going to look like. So a is the initial value, and then b is the growth rate. Decay factor, growth factor, whatever it might be. This one's actually decaying because it's less than 1. So What I would do on my assignment is I would write that down. Let me slide this out of the way a little bit. So 310, 606, remember that. Y equals 310, comma 606 and 0.04. Let's say 0.04 times in parentheses my growth or decay factor minus 0.998. We'll go with that. 0.998, and we're going to raise that to the x power. Now, depending on how it looks, use fancy math script or something, maybe make it look better. This is good enough. I have an initial value and a growth or decay factor raised to the x power. This is good. Here's my exponential model. The next part, I'm asked to predict the population of your city in the year 2020 using the exponential model that you came up with. Well, X is the number of years since 1950, so for 2020, that's 70 years later. So you're going to plug in 70 for X, do the math, and write down your answer. Same thing for the next one, predict the population in 2050. Well, that's 100 years later, plug in 100 for your equation. Now guess what? Because I stored my regression equation as function y1, I don't need to necessarily plug in 70 by hand and do all this work. Watch this. Y equals, notice my function is typed in there, unrounded and everything. The full decimals as big as they need to be, ready to go. If I hit graph, I'll have a curve that goes through those points. Now, again, mine's pretty inaccurate just because of the weird way that the population of St. Paul moved in the last 60 years, but we'll deal with it. Now, if I want to know what the population is going to be in 2020, just off my screen, I'm going to check my table. When you go to your table, you probably see something like this. Now, here's corresponding X values. That's going to be a particular year. Let me get down to 0. So in the year 0, which is 1950 in our case, that's what I got. And I could keep scrolling and scrolling. I'm not going to scroll all the way down to 70 because that would be ridiculous. So instead, I'm going to change my table settings. Hit second window to go to table setup. I can set my table to start at 70, but I don't want to mess with that. I'm going to change the independent variable to ask mode. Here's what that does. When I go to the table, it's blank. That's because my calculator wants me to enter X values. It's asking me, hey, what would you like me to evaluate? I want to know what happens when I plug in 70. So I'll do so, and there's my population. So according to my model, population of St. Paul will be about 269,524 people. I'll write that down. 269,524. Then I do the same for the second one. Well, in that case, plug in 100. Hey, after 100 years, what's population going to be? 253.65. All right. So that's using your graphing calculator to find an exponential model and use that exponential model to predict future population or whatever else it might be. Last part of your worksheet, I would like you to do this. List 3 things your city's government might have to think about changing based on your projected population change. So as they decide what to do with infrastructure, roads, buildings, maybe public school systems, or number of policemen, cops, whatever, firefighters, whatever it is, different things the government's in charge of. Those things need to adjust to populations change. So think about a couple factors that might need to change for your city and its population growth or decay. And that'll be it for this lesson.